Okay, we're moving into chapter 2. And one of the things I want, so section 2.1 is what I'm going to talk about first of all here. So let's get going. I'm going to go ahead and move into chapter 2, which is right here. All right, now let's move on. So section 2.1, rate of change and the derivative. So we're going to talk about equations for the tangent line and the normal lines. Remember, a normal line is a perpendicular line. So the tangent line, so if you get the slope of the tangent line, then you need the perpendicular line is going to have a slope that is the negative reciprocal of that original tangent line. Remember that, negative reciprocal. You got to flip and make it negative. So one of the situations is, remember that if you multiply together a line and its perpendicular slope, the slope of a line and its perpendicular slope, you should get -1. Tangent line, so a tangent line and the perpendicular to that tangent line, you multiply those slopes together, you should get -1. Okay, we're going to talk about the rate of change of a function and the average velocity and instantaneous velocity and the derivative of a function at a specific value. Okay, let's get going. So, definition of tangent line, what we've talked about before is in the diagrams that we've worked with. Let's go back down to that next page and show a picture again to remind you of this. The slope of this tangent line, the way they've typically determined it, is if you start off with x1 way out here and look at the slope of that line, and then start getting closer and closer and closer to C. The slope of the lines as you're moving in the slope of those lines is getting closer and closer to the tangent line until when you get to C, the limit as x approaches C is going to be the slope of that tangent line. Okay, you remember that from previous past life type moment there. But here's the situation. So remember what we've got is the slope of the tangent line is that the limit as x goes to C of that change in y over change in x. The slope of each of the lines as you're getting closer and closer and closer approaches, and as you get closer to C, it actually becomes the slope of the tangent line, right? And this limit occurs so frequently is often given the special notation of f prime, okay? F prime of C is meaning the slope of that tangent line. Okay, so that indicator, that slope, f prime, is indicating derivative. It's indicating slope of the tangent line. Okay, let's keep going. So here we go, the equation of the tangent line. I'm not expecting you to memorize this. Okay, if you've got, remember, if you've got x and y, if C is the x value and f of C is the y value, then it can get kind of cumbersome to put this over here into a formula format. Don't worry about memorizing this. All it's saying is, remember I talked to you about the point slope form, that if you've got the slope m equals f prime of C, and if your x is C and your y is f of C, then y minus y1 f of C equals m times x minus x1. Again, don't worry about memorizing. This is just know that this is the point x, y, x, f of x, C, f of C, that's your point, and f prime of C is the slope. So it's x and y and m are right there in that situation. Again, it talks about perpendicular line is the normal line, like I said a moment ago. All right, let's keep going. All right, so the first question, I'm going to be asking you this on the test at some point to write the slope, write the equation of a line. So you're going to need to know the slope of the tangent line of the curve f of x equals x squared is the problem given here. So it's saying find the slope of f of x equals x squared at a specific value C equals -3. Okay, think about that as a parabola, right? And -3 is over on the left-hand side, so the line is going to be going downhill. It's going to have negative slope. Like they get here, the slope is -6. But take a look here. So f prime, the slope of the tangent line, is equal to the limit as x goes to C, -3, of f of x minus f of C, -3, over x minus C, which is -3. Plug those values in, and notice what's happening here. as x approaches 3 when you get a difference of squares on top, in this case. Okay, it turns out that you end up with, and that's factorable, and it turns out that that cancels, one of those factors cancels off with the denominator. Boom, boom, and you end up with x minus 3. Now that's typically going to happen when you're doing these problems. The denominator is going to cancel with one of the factors in the numerator, most commonly, okay? Sometimes that may not happen perfectly, but that's usually the case. And as a result, when you get to the end and the denominator is gone, then you can plug in -3 into the function because it doesn't cause the denominator to make equal 0 anymore. You get -3 minus 3 is -6, that's the slope. So then you go back, you got your point x, x, y, and m is this. So there's a bunch of different ways to do it. This is using the formula they gave, but you end up with y equals -6x minus 9. That's the equation of the tangent line. And I will ask you to be able to do that downstream. All right? Find the equation of the normal line means do the same thing. It's the same point, -3, 9, but it's perpendicular to -6. The slope is -6. We need to flip it and change the sign. So that becomes +1/6. This is 6 over 1, -6 over 1. It becomes +1/6. Plug that into this is the point slope form, and you end up with this function. If you plugged it into y equals mx plus b, it'd give you the same result. Okay, so let's keep moving. Oh, and here are the two functions that they gave. The parabola is in blue, the tangent line is in green, slope is -6, and the perpendicular line, the normal line through that point, 3, 9, -3, 9, excuse me, is going to have the slope of +1/6 here, +1/6, etc. All right, let's keep going. All right, instantaneous rate of change. We know the average rate of change is if you've got an interval, you take the endpoints and change in y over change in x and get your answer. But instantaneous rate of change is what you get when you bring it down to a specific point. So if it's ever you ask for an instantaneous rate of change, that's saying what is the slope, the rate of change at a point, at a value, okay, at one point. Normally we've got 2. This means the limit as x goes to c, that's the situation. That's instantaneous rate of change, often shortened to rate of change. Okay. Now, here's an example. Find the rate of change of the function f of x equals x squared minus 7x. Okay. So there's 2 things you need to write, okay, 2 things that you're going to need. Rate of change is going to be the slope. Okay. So in the process of doing the problem, though, you are going to need f of 3. So f of x minus f of c means 3 is c. Therefore, you got to plug in 3. That means you got to plug 3 back into the original function. So you need f of x minus f of 3. They plug 3 into the function and get 9 minus 21. And that gives you minus 12. So the coordinates are 3 minus 12. And then you got to go back in and find the slope. Find the rate of change now, and that means plug it into this whole situation. Now, when you plug this in, you plug 3 into here, you get minus 12. But if you plug in 3 into the original function, right, you get minus 12. So you've got f of x, which is the original function, minus f of 3, which is the minus 12, and then you got x over 3 in the bottom. And it's going to turn out typically that one of the factors of what's on top is going to cancel with the factor on the bottom, okay, with what you got on the bottom. So it's a matter of factoring this out, recognizing 4 and 3, 6 and 2, 12 and 1. 4 and 3 gives you -7 when the signs are the same. So the x minus 3's cancel, you're left with x minus 4. They were a little careless here on their, this is a sapling write-up, Macmillan. The idea is parentheses around this would be a little bit more clear, okay? Then if you plug in 3 into this, you get 3 minus 4, which gives you minus 1. So the slope is minus 1, and if it's asking for the rate of change, that's minus 1, and you could plug it in if you were asked for the equation of the line, tangent line. All right, so the solution rate of change, and then it says for any value. So they're saying here, don't plug a number in for c. Let's just plug in c and see what we get, all right? And c, haha, plug in C and see what we get. The situation is we got f of x minus f of c. So f of x minus f of c, right? Plug those in and see what you get out of it over x minus c. And it's going to turn out x minus c is going to be a factor of what's on top again. So you get f of x minus f of c, distribute that minus sign. And if you split it up, they do mathematics here, you get a difference of two squares when you subtract the xc squared. Difference of two squares is x plus c, x minus c. And when you leave this multiplied out on this side, you end up with, you get minus 7 x minus c. Well, you've got x minus c is common here. Factor that out front. Bingo, x minus c is common. Therefore, what you got left is x plus c minus 7 right here. And the x minus c factors out, cancels. And again, they don't put the parentheses around here. It's a good habit to get into. This could be read as the limit as x goes to c of x. But it's this whole thing needs it. So the parentheses there, you do it. And when the x is replaced by c, you get c plus c minus 7, which is 2c minus 7. And if you notice what the derivative of this is, you get 2x minus 7. We'll be talking about that later. Those of you with some experience, you see that. That's what we're talking about there. Let's keep going. All right, they give an example here. I think it's a little bit cumbersome. Let's just move on right now. I think it's good to be able to plug it in and work it. But the main idea is I want you to be able to solve the problem in a certain sense of the word. So average velocity, if you're checking to find the average velocity, the difference at two different times, plug those two different times into the function, and then subtract the two different times in the denominator, get the difference on top, difference in the bottom, and that's going to be the average velocity, for instance, in this case. So the f with one time plugged in minus f with another time plugged in over the difference in the times, that's going to be the average velocity. They give an example here. The bridge, you're dropping a rock, falls at a certain rate. So you plug the two times in. The two times are at 0 when you drop it. And at 7.458 seconds, and you can get that right off the top of your head. I know, when you're dropping a rock, you count to 7, 1, 2, 3, 4, 5, 6, 7.458. I'm sure you know 0.458. That's a little bit of blown away, but it gives you an exact answer when you plug 0.458 into the situation. You get 890, 7.458. So it comes off into being 890 minus 0 over the difference in the denominator, and you get 119.335 feet. Go over that another time if you want to, but that's just the logic of finding the average velocity. Instantaneous velocity, now what we were talking about is as the two times get closer and closer together, the limit as t approaches t sub 0 of the difference of the times over, the difference of the time plugged into the function over the difference of the time. And that's going to be the instantaneous velocity of the situation. So if we're talking about at 1 second, we're finding out what the velocity is at 1 second, finding velocity. Then you get at 0, you get the regular t minus 1 second, minus f of that 1 second, all right, over the t minus 1. This is the regular function. And so you plug in the regular function, 16t squared was given in the previous, f of t is 16t squared, and t sub 0 is equal to 1 from the previous information given. So part of what I want you to see is that the situation is the change in y over the change in x. Again, factorization, the denominator is going to cancel with something in the numerator. Difference of two squares. It is a difference of two squares. If you factor out the 16, you get t squared minus 1, which is the difference of two squares, which factors in the t plus 1, t minus 1. They cancel, and you end up with 16 times t plus 1, etc., and plug the 1 in, and you get 32. So the velocity at 1 second is 32. All right, so, and they're showing the shortcut form of how to do that. Anytime t sub 0, they plug it in. Notice the factorization happens. You get a cancellation. it does cancel, the minuses cancel, and you end up with t plus 0. When you plug that in, you end up with, as t approaches t sub 0, you get 2, right? Oh yeah, you get 2 t sub 0s. As t approaches t sub 0, you get t sub 0 plus t plus sub 0, which is 2 t sub 0. 16 times 2 t sub 0 is 32 t sub 0. And if that was too quick, go back over it again and verify it. Derivative of a function at a number. Therefore, we went through that a little bit ago. The derivative of a function at a number, c, is f of x over minus f of c over x minus c, and it's the limit as x approaches c of that. That's the arrangement of that. So if you're asked to find the derivative at a specific value, the derivative, which is the slope, which is the rate of change, all those different things that are happening on, the different names we have for it, then take f of x minus f of c, plug in 2 into the function to get that value. So what you end up with, f of x, is all of these numbers together. If you plug 2 into the function, you end up with, what is that? 12 minus 4, 12 minus 8 is 4. So you end up with f of 2 turns out to be 4. That's where they get that. So you plug in f of x minus f of 2, which is 4. And then you're going to find that when you put this together, it's going to factor into something that does have a factorization, which gives you x minus 2 as a common term. And tell you what, let's go through that really quickly. I'll tell you what, 2's cancel. You get the limit as x goes to 2 of this function that's left over. These 2 cancel. And you plug, notice they've got parentheses this time. That's nice. That's a better way to write it. As x goes to 2, you end up with 6 plus 4, which is 10. So the derivative of this function at x equals 2 is 10. So the slope of the tangent line at x equals 2 is 10. The next part is 4.2. I'm going to stop here, and we will do a separate video for 2.2.